Okay, so now some of the most beneficial stuff we can do with logs, solving equations. Okay, like I told you guys before, when you're working with log, it's a symbol. You can't just divide off a symbol. Like I can't come over here on the left side and say, hey, let's divide by the word log. That'd be fun. No, not so much. You can't just divide off a square root sign. You can't just divide off absolute value bars. It doesn't work that way. So whenever you want to solve an equation that has log and you want to get rid of it, use that tool that converts it to exponential form. So start with your base, go across the equal sign to get your exponent is equal to 2x plus 5. This is how you drop the log part. You just take it out of logarithmic form and you put it into exponential form, just like this. So 2 cubed equals 2x plus 5. Simplifying this up, so 8 is equal to 2x plus 5. Let's move that 5 on over. So 3 is equal to 2x, and x is equal to 3/2, just like that, and you're easily solved. Okay. Example 14. With example 14, again, I want to solve. Okay, but this time's a little different because I can only take it out of logarithmic form into exponential form if I only have one log, and I have more than one. I've got this front term and a second term. Okay, well, don't we have a property though that tells us how we can combine when we have several logs? All right, and the fact is they're connected with the minus sign. So they're both the same type of log. It's log 5 and log 5. So let's write log 5. And remember, when they're connected with the minus sign, we're making a fraction. The positive one goes in the top of the fraction. The negative one goes in the bottom of the fraction. Just like that, and it equals 1. Okay? If that connection sign was a plus sign, then we would just multiply 2x plus 1 times x minus 2. But it connects with a minus sign, so half of it has to go to the bottom. Okay, now from here, we can take it out of log form. Start with your base, go across your equal sign, and then come back to set it what it's equal to. Okay. From there, just to finish cleaning up, let's get rid of the fractions. Let's multiply both sides by x minus 2. And backwards distribute here, so 5x minus 10 is equal to 2x plus 1. Let's move that 2x over. Let's move that 10 over. We get 3x to be 11, or x to be 11/3, just like that. Okay, so let me just do that. Like I said, let me just do what ifs. If that said solve log base 5 of 2x plus 1, and then plus log base 5 of x minus 2 equals 1. So we kind of mark that off. Then what you would do is, since these are both two logs and they're connected with a plus sign, what we're going to do is we're going to multiply then 2x plus 1 times x minus 2 equals 1. Take it out of log form. So 5 to the first is equal to this product. And then you just go from there. Okay? But let's go on to example 15. All right. Okay, so now here with example 15, we have, this time instead of having logs in there, we want to get rid of the logs, we're in the exponential form. So this is now how to solve when our equation's in exponential form. Okay, always want to isolate, just try to get the exponential part by itself. So it's really the e, the base to the power. That's what I mean by the exponential part. So to get started with, we have the 5e to the negative 2t equals 6. It's just 5 times that. So let's break off that coefficient in the front. So now all I'm focused on is just the exponential part, e to the negative 2t equals 6/5. Okay? Now, basically from there, what we can do is take it from this form and now put it back in log form if you want to. Okay? So it's like start with your base, because your base is going to be the same base for the log part. And just because we're in the case where our base is an e, I'm not going to really use log, I'm going to use natural log, okay? So natural log, the base here is e because the base over here was e. What it equals 6/5. That's what we're taking the log of, or the natural log of. And what the power was is what this is going to equal. Okay, just like that. And in the last step, all you have to do in order to get the t by itself, obviously, is divide off that coefficient. So divide by -2, and there's your answer. So the natural log of 6/5 divided by -2 is equal to t. And all I would have to do is plug that in a calculator, and I would have my exact answer because you're taking the natural log of 6/5. Okay? Now, again, like I say, just to play what ifs, if by the time we got to this step right up here, let's say it was something like 3 to the -2t equals 6/5. Okay? So in this case, since my base is not e, it's something other than e, then what I would have done is use the word log. Okay, so if the base is specifically e, go ahead and do natural log, but if it's not e, then just do log. So it's log base 3. What your exponential function equals is what you're taking the log of. So 6/5, and then the exponent is what it equals. So just like that, then you would divide both sides again by -2, and you would have your answer either way. Okay, let's do number 16. We want to solve, again, 12 minus e to the 0.4t equals 3. So again, it's another function. It's an exponential. And like I said before, let's just focus on isolating the exponential part. So first thing, let's subtract 12. So negative e to the 0.4t is equal to 3 minus 12, which is -9. And then just divide off that negative sign there. So really we're looking at e to the 0.4t is equal to +9. Alright, the base here is an e, so let's go with natural log. We're going to keep the e. What this equals is what you're taking the natural log of, and the exponent comes over here on the right. So again, just to check, this would be then, if I convert it back the other way, it'd be e to that power equals 9, which is exactly the way it is. And to wrap this up, just divide off that coefficient off t, and then you get a final answer of t being the natural log of 9 divided by 0.4. Okay.